All right, so we're still talking about multiplying polynomials. Today we're going to be doing more of the distributive model, but they're going to be a little bit more complex than they were last time. So one thing that we kind of need to review before we get started is one of our properties of exponents. Okay, so one of the things we talked about when we did exponents last year was the multiplying property of exponents, which basically means that if I have, let's say, x to the fourth, and I times it by x to the third, what do we do with those two? Well, you just add the exponents, right? Because basically this is 4x's, and this is 3. So they're all multiplying together. If you think about that, that's the same as multiplying x by itself 7 times. Okay? So that'll help you as we go through this. And that's why x times x is actually x squared, because it's like x to the 1 times x to the 1, which is x squared. Okay? Now, multiplying polynomials. Again, we're going to be using the distributive method mostly today. And we're going to get some pretty big expressions, which is perfectly fine. We're just going to have to go at, multiply it all out and then simplify everything after we do it. So let's start out with some of our basic ones. So let's just start. This one just has a single term multiplying with this group, which is perfect. That you should all be able to do this just fine, right? You just distribute 8v to everything in the parentheses. So 8v times 7v. So the 8 and the 7 would multiply. And we're going to get, oh man, losing my times tables. 56. So 56. And then the v and the v would multiply, getting v to the second power. And then we do the same thing with the 2, but 8 and the 2 would multiply to become 16. And then we just have the v. Nothing more I can do to simplify that, so that's my answer. Easy enough, right? Let's do something a little bit more complex. Let's look down here at number 5. So this one has a binomial multiplying with a binomial, which we talked about this last time. We did the area map, right? And you just don't really have the space to do that. But again, I showed you just quickly how to do it using the distributive model. Again, the v would just multiply with both terms here, and the negative 8 would multiply with both terms there. So when we do that, v times 5v, 5 doesn't have anything to multiply with, so it just stays there, but the v and the v would become 5v to the second power, and then v times 6 would just be 6v. Okay, then we do the second term. Negative 8 times 5 is negative 40v, and then negative 8 times 6 would be negative 48, right? Yeah, negative 48. Now, still not quite done. We can simplify this a little bit, right? 5v squared doesn't have any like terms because there's nothing else with a square above the v. But these two, 6v and negative 40v, can combine, and we're going to get 5v squared minus 34v minus 48. And that is going to be my final answer. Not too tough, right? Now let's look at something a little trickier. So let's look at number 11 here. Number 11 is a trinomial multiplying with a binomial. Now, it's going to be just like this, where each term has to distribute, but we have 3 terms here that have to distribute to both of the other terms in the binomial. So this 6p has to multiply with both terms. This 2p has to multiply with both terms. And this negative 4 has to multiply with both terms. So we're going to get kind of a big number, and there's going to be several like terms to simplify, but let's go through this just doing one distributive thing at a time here. So we'll start with the 6p squared. 6p squared times 7p. We couldn't combine these if we were adding, but since we're multiplying, we can, right? The coefficients multiply with each other. The p's multiply with each other. So 6 times 7 is 42. Answer everything, right? So 42. And then p squared plus or times p is like 2 plus 1, which would be to the third power. Okay. Then 6p squared minus times negative 7 would be negative 42 p squared. Okay. So that's what we get from distributing the first term. Now we're going to distribute the second term. 2p times 7 would be 14p, so plus 14p. 2p times negative 7 would be minus 14, or it's 14p squared, and then minus 14p. Okay? Then the last one, the negative 4, multiply it. 7 times negative 4 times 7 is negative 28p. And then negative 4 times negative 7 would be positive 28. So plus 28. Okay. Now we've got a whole bunch of numbers here. And we're going to try to simplify it. So first thing I'm going to do is I'm going to look for like terms. Do I have any other p cubes? Nope. So that one's just going to stay by itself, 42p to the third. Okay. Then p squareds. Looks like I got 2. So, wait. Should I? Yeah, I should. Yeah. So I have negative 42p squared and positive 14p. So combine those, and I am going to get negative 28p squared. Okay? So those combine to become that. Next, I've got negative 14p and negative 28p. So combine those, and I'm going to get minus 42p. And then I only have one constant, so plus 28. Okay, so that is as simplified as I can get, because none of these have the same exponent, so I can't combine anything else. So that is my final answer. Not too tough, right? Works out pretty well, and if they're already in the proper order when you multiply it, this is why we have a proper order, you'll notice that they kind of group themselves when you multiply it, so it makes it pretty easy to combine them. So let's do one more. Let's do a trinomial and a trinomial. So let's do this one right here, 15. So again, each term has to multiply, whoops. Oh man, I'm terrible at drawing these rainbows. It's alright. You guys do better than me. And then, okay, so we're gonna get 3 terms from each of these multiplying. So this will be fun. So 5m squared is gonna multiply with each term over here. So 5m squared times 8m squared is going to be 40m to the 4th, right? Because 5 times 8 is 40. M squared times m squared is to the 4th power, because you just add the exponents. Okay? And then 5m squared times 4m, I'm going to get plus 20m to the 3rd. And then 5m squared minus 5 would be negative 25m squared. Okay? Now, we move on to our next, and we're not going to have as nice of a setup with the binomials, but we can still easily find the like terms. So 2m is going to multiply with each term here, so I have 2m times 8m squared would be 16m m to the third. Okay, and then 2m times 4m is 8m squared. And then 2m times negative 5 would be negative 10m. Okay, whew, still not done. Got 3 more to go. 3 times 8m. And again, you're just multiplying the coefficient there. So 3 times 8 would be 24. So 24m squared. And then 3 times 4m would be plus 12m. And then 3 times negative 5 would be negative 15. All right. Whew, that's a big number, right? Let's simplify it. So do I see any m's to the 4th power? Just the 1, right? Perfect. It stays in front. Okay, now I'm looking for cubes. I've got 1, 2. So 20m and 16m, they're both positive. Combine them, you would get 36. So plus 36m cubed. Okay, now I'm looking for squares. So I've got negative 25m squared, 8m squared, and 24m squared. So that would combine, see, negative 25 plus 8 plus 24. I'm going to get 7. Right? That doesn't sound right. Negative, no, that's right. Okay, so I get 7m squared. Okay, now I'm looking for just m's. I've got 1, 2. Negative 10 and 12. Combine those, you're going to get 2. So 2m. And then there's only one constant, so minus 15. And that gives me my final answer there. And you'll notice all these final answers are usually one term shorter than they were when they started. There are technically 6 terms here. There are 5 terms in this answer. There are 5 terms here. There's 4 terms in this answer. There are 4 terms here. There's 3 terms in this answer. It's kind of what happens when you're multiplying polynomials. Now, some of these can be a lot of work, but it's not really hard. It's just a little tedious, right? Multiplying these is pretty simple. And that's how you multiply numbers, polynomials, using distribution.